So, to complete our discussion of L'Hopital's rule, we have to finish and say, here are the last three indeterminate forms that we could encounter while taking limits. All right? And they are in the form 1 to the power of infinity, 0 to the power of 0, or infinity to the power of 0. Now remember, we're not talking about a value 1 being taken to the infinite power. We're talking about some expression that approaches 1 to the power of some expression that approaches infinity. We're not talking about 0 to the 0th power. We're talking about some expression that gets close to 0, taken to a power that also is approaching 0. All these are indeterminate. And the question is, what do we do about them? And the answer is the active application of logarithms. Danny, I love logarithms too. I heart logarithms. I would do worse than if I could.
I hate logarithms.
All right. So here's the general rule. If we encounter one of these indeterminate forms, what we're going to do is take the logarithm of them, all right, and see if we get a finite limit. If we get a finite limit, then we can use that on the power of e to find out what the real limit is. Shall we try it in practice? Yes. Sure. Maybe this will work. I got a bad feeling about this.
Luke Skywalker. Obi-Wan.
Wait, I got a bad feeling about that. That's actually a conflict, isn't it? I got a bad feeling about this kid. That's right there. Okay, so is this problem in an indeterminate form? Of course it is, otherwise I wouldn't be doing it as an example in this section. Which indeterminate form is it in? It looks like as x approaches infinity, 1 over x goes to 0. So the thing that we're taking the power of is approaching 1. But the power is going to be going off to infinity. So this is indeterminate in the form 1 to the infinity. Now, what can we do about this? Well, we're going to take the natural log of it. We're going to do some side work. The limit as x approaches infinity of the natural log of 1 plus 1 over x to the x. And that's equal to the limit as x approaches infinity. I believe the rule is called, at least at Berkeley High, the bring it on down rule. Like this, and I'll pause until someone tells me what I'm going to do with it. I'm going to bring it on down. I'm going to take it and put it there. And now I've got the natural log of 1 plus 1 over x. What happens when I apply infinity to this one? Well, x is going to go to infinity. Over here, I'm going to get 1 because as x gets big, the 1 over x turns into a 0. I get 1 plus 0. The natural log of 1 is 0. I got something that is now indeterminate in the form infinity times 0. We apply the trick that we learned yesterday. And then I'm going to rewrite this. The limit as x approaches infinity of the natural log of 1 plus 1 over x divided by 1 over x. I take this x, and I bring it into the denominator and change it into its reciprocal. These two expressions are equivalent. And I do that because while infinity times 0 is indeterminate, it's not a form in which I can use L'Hopital's rule. But this form is in the form 0 over 0. I may use L'Hopital's rule in that form, and when I do so, I get the limit as x approaches infinity of, see, the derivative of natural log is 1 over 1 plus 1 over x multiplied by negative x to the negative 2. And then on the bottom, I'm going to get another negative x to the negative 2 as I take the derivative of 1 over x. Behold, the red pen. And I get the limit as x approaches infinity of 1 over 1 plus, I guess I forgot to calibrate the board. There we go. What happens when I apply infinity here? This thing becomes a 0. We get 1 over 1. So it's equal to 1. Now, if that's true, this is going to equal to the limit as x approaches infinity of e to that power. Why? What did I do over here to our original equation? I took the natural log. How do I undo the natural log part? You take the e of it. And so our ending answer, it doesn't even have an x in it. And that is, it's going to equal to e. So, pull the power down, deal with it that way. You may put a L'Hopital rule there. When you're done, bring it back to the original thing, but put it as the exponent on e and finish off the evaluation there. And according to the exercise, that's exactly right. Should we try another one?
Yes, please.
Okay. We ready to change slides? Yes? No? Here we go. All right. Your turn. Your turn. Talking. Sharing.
Wait, is that x approaches 0?
It's the limit as x approaches 0 from the positive side of x to the x.
Okay, so this is the 0 to 0 form because as x approaches 0.
Yeah, I suppose so.
So we can use.
0 to the 0.
I'll sit over here
So we
and
had to remove
try not to interrupt you guys.
So this is in the form 0 raised to the 0, right? So, first thing we need to bring the x down.
the limit as x approaches 0 of x natural log x. Well, as x approaches 0, x is 0. But as x approaches 0, natural log goes to negative infinity. That means that that last blue step is indeterminate in the form
Yeah, it's
0 times infinity.
the thing about this
Which is
it's
indeterminate,
not
but
in
you
a-
can't apply locals.
This is where you
So
just
I have to
there.
get it
It's
in a
not
form
like
in
approach
which I can
infinity.
apply locals.
It's just
So
you
1
can't
over
take
x in the
elements.
denominator escaping.
So what you end up doing
Exactly. 1 over, instead of multiplying by x, I'm dividing by its
1
reciprocal.
over 0, which is infinity, and ln x 0, which is infinity over 0.
Now I'm in the indeterminate form, infinity over infinity, and now I can apply L'Hopital.
divided by negative x to the negative 2. Reset.
Oh wait, we're going to do the,
Yeah.
doing the derivative.
Well, no, not exactly. Yeah. Then I take the
Yeah,
derivative.
so it's 1 over x. ln x.
So then,
Wait, so 1 over x, you do one of these times 1. And then 1 over
then this is the derivative.
negative 1 over x.
1 over x is negative x.
It'll be
Negative x.
negative x to the.
So then you bring this up because of the negative exponent, and you end up getting negative x squared over x, which ends up being negative x, which as that approaches 0, it equals 0. So we were right. We just missed a few steps. So it's limit as x approaches 0.
So this is like x to the negative 2. So you have x to the negative 1 over negative x to the negative 2. You just flip them. That's like negative x squared over x.
Will that always be like an E you replace it with?
Yeah,
Oh.
because again, because if you manipulate it first by rewriting with the natural log, you got to undo the natural log.
Oh, okay. I wasn't sure if it was just like a one time.
No, it's always going to follow that process.
Because when you have a negative on top and a negative on the bottom, the negative on top means that that should be the denominator. The negative on bottom means that that should be the numerator. So you just flip. So the negative x.
And is there any teams that are very good?
Now, do you? So no matter what, if you give us your answer on the side, it'll be e to that.
E to whatever I get over here.
So it's just that first equation. That
Right.
first equation gets taken care of.
Correct. All right. Right, now you're ready for the rest of them. That's it?
Yay!
Oh, I don't think so. We are behind. We have to get started on the notes for next week. We're not going to. I won't make an assignment for the other part, but we do need to get started. Is that all right?
And our quiz is tomorrow, right? On 8/1.
Monday.
Yeah. I'm sorry. That should be 29 to 30. 29 to 51 odd.